Hi everyone. So in this video, I would like to give a brief overview of the course. The main topics of this course are extensions of linear models. Remember that the linear model takes the form of this: y is equal to beta naught plus beta 1 x1 up to beta p xp plus epsilon. Here, x1 to xp are predictors and y is response. So these are given by data. For example, x1 is height of animals, and x2 is maybe temperature of those animals, and y is the weight. So we explain y by height, so the weight by height and the temperature of the animals. So individual animals, so the sample unit is one animal of maybe specific animal such as beaver. Then if we want to explain y by linear combination of these predictors, usually the coefficients are unknown. Maybe beta naught, I don't know. So the beta naught is some constant, and the beta 1, for example, for each additional the centimeter, maybe the weight is maybe the 50 grams more or something like that. But the beta 1 is unknown. So the data estimates this beta naught to beta p. And epsilon is error. So even if the height and temperature of animals are known, weight is not 100% predictable. So we have some error. So that is epsilon. So epsilon is called an error term, and expectation of epsilon is assumed to be 0. Also, it is often assumed that epsilon follows the normal, the 0 sigma square. Here, sigma square is another parameter similar to beta, and the epsilon are independent for all observations. So such assumption is made for linear models. So here, epsilon is random because this is an error, and the other terms on the right-hand side is not random. So y is again random. So y and epsilon are random, and the others are non-random. And x and y are observed, and beta are not observed. We have to estimate those. Okay, so how to extend these linear models? So first topic is generalized linear models. So this is the main topic of all of these. So the response y sometimes takes values in a set different from the real numbers. For example, the weight, maybe weight cannot be negative, but for example, if y is temperature, then temperature also doesn't go below something, but often y is just the continuous variable. If, for example, all animals' weight is between, okay, so 100 grams to 900 grams, then, and approximately normally distributed or something, then just we assume that is a real number. But sometimes the y is totally different. For example, the y maybe is a 0 or 1. For example, that we want to predict the whether a patient is benign or malignant by some demographic information such as weight or height or blood pressure. So in such a case, the y is totally different from the y. The range of y is totally different from real numbers. Sometimes this is also categorical. So think about the character recognition problems. So we have A, B, C. We have some features of the characters given by pixels. Then the output should be A or B or C. So this is the categorical. So it's different from real numbers. Sometimes the numbers are counts. So think about the, which town have COVID-19 cases today. that number is probably small, either 0, most towns have 0, some towns have 1, 2, some towns have 10. So in such a case, the treatment of y is totally different. And also the sum y ranges only between 0 and 1, typically ratio. For example, the proportion of people who voted for Trump in 2016. So if we collect such data for each town, that is between 0 and 1. So that is different from the variable which ranges from negative infinity to positive infinity. And also, of course, the many variables have range, the 0 to infinity. So if the y values are well distributed, then usually we don't really care about the limit, such as 0 or 1. But if, for example, the most observations are very close to 0, but a few observations are large, in such a case, it's different from the usual. We have to prepare something different from usual linear model. Okay, so the second topic is mixed effects models. So this is also important topic in this course. So the point is some sample units are nested. So errors, epsilons, are dependent. For example, the sample consists of 150 people from 40 families. So we, for example, examine some, so we do some survey on 150 people, but we don't have enough budget to take 150 independent people. So we just select 40 families and we ask survey, we do survey on those 150 people in the 40 families. So in such a case, the people in the same family have some relationship. For example, if we think about the body mass index of all people within household, there is some tendency that all people have overweight, or all people have underweight, and so on. So in such a case, we have to consider error terms of 150 observations are dependent. So we study these models. And if we have time, we study the non-parametric models. So this is the model that the response y is not explained by finite number of parameters, beta 1 to beta p. And also yes. So non-parametric means that the parameter is not finite. But in reality, the data set is usually finite. So if we have 150 observations, if you have 150 parameters, usually you can explain everything, right? So what's the meaning of finite number of parameters? So that is actually finite and fixed with respect to sample size. Okay, so if we increase the sample size, then we have to increase the parameter size. So that is not parametric model, but we say non-parametric models. So this is one example. So given a new observation, the x1 to xp, for example, the height and height and maybe temperature of an animal, so a new individual animal. Then y may be explained by the closest observation in the original data set. Okay, so suppose in the training data set, originally we have 150 observations and we constructed a model and we get a new observation x1 to xp and how to predict y for this new observation. Then if this rule is used, basically we have to search for the closest observation to this new observation. Okay, so we match the individual for new animal that we search for the closest individual which have the similar height and similar temperature. Then we can predict the weight of that animal. So so that is not actually expressed by a simple model with finite and fixed number of parameters. So in such a case, we have to use different strategy. So if we have time, that we discuss this model.